Okay, so introduction to earthquake. So, what is an earthquake? So, an earthquake is what happens when two blocks of the earth suddenly slip past one another. The surface where they slip is called the fault or fault plane. The location below Earth's surface where the earthquake starts is called hypocenter or focus, and the location directly above it on the surface of the Earth is called the epicenter. So sometimes an earthquake has four shocks. So these are smaller earthquake that happens in the same place as the larger earthquake that follows. Scientists can tell that an earthquake is foreshock until the larger earthquake happens. So next is the largest main earthquake is called the main shock. So main shock always have aftershock that follow. These are smaller earthquakes that occur afterwards in the same place as the main shock. Depending on the size of the main shock, aftershock can continue for weeks, months, and even years after the main shock. So, what are the causes of earthquakes and where do they happen? So, recall, Earth has four major layers: the inner core, outer core, mantle, and crust. The crust and the top of the mantle make puzzle pieces like thin skin on the surface of our planet. These puzzle pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces as tectonic plates, and the edges of the plates are called plate boundaries. The plate boundaries are made up of many poles, and most of the earthquakes around the world occur on these faults. Since the edges of the plates are rough, they get stuck while the rest of the plates keeps moving. Finally, when the plate has moved far enough, the edges unstick on one of the fault and there is an earthquake. How do scientists measure the size of earthquake? So they use the seismogram recordings made on the seismogram at the surface of the earth to determine how large the earthquake was. Geometric classification of faulting. So we have the dip slip. So movement occurs when the hanging wall moves predominantly up or down relative to the put wall. So as you can see here, so we have put wall, then the hanging wall. So that's it. The motion was down. The fault is called normal fault. If the movement was up, the fault is called reverse fault. So this is a reverse fault. This is a normal fault. When the hanging wall moves horizontally, a strike slip earthquake. Yeah, it's called strike slip earthquake. If the hanging wall moves to the left, the earthquake is called right lateral. If it moves to the right, it's called left lateral. When the hanging wall motion is neither dominantly vertical nor horizontal, the movement is called oblique slip. Although oblique faulting isn't unusual, it is less common than the normal reverse and strike slip movement. So here you can see here the oblique movement. Measuring the size of an earthquake. So we have the amplitude. It is based on the amplitude and distance measured from the seismograms. So the most common scale is the Richter scale, which measures the magnitude on logarithmic scale. Magnitude. It is a quantitative measure of size of earthquake at the source. The Richter magnitude scale measures the amount of seismic energy released by an earthquake. Because of the logarithmic basis of the scale, each whole number increase in magnitude represents a tenfold increase in measured amplitude. As an estimate of energy, each whole number step in the magnitude scale corresponds to the release of about 31 times more energy than the amount of associated with the preceding whole number value. So, for example, magnitude 5 and then magnitude 6. So magnitude 6 is 10 times the magnitude of magnitude 5. But magnitude 6 is 31 times more the energy of the magnitude 5 energy release. So here you can see the seismometer that will give records on the earthquake. So we have here the 2, 3 seismometer, and here is the focus or the epicenter of the earthquake, and it will give us this reading on the seismograph. So amplitude is the height. Okay, the height of the graph. Magnitude, Richter scale. So magnitude less than 3.5 is generally not felt but recorded. 3.5 to 5.4 are often felt but rarely cause damage. Under 6, most slight damage to well-designed buildings can cause major damage to poorly constructed buildings over small regions. 6.1 to 6.9 can be destructive in areas up to about 100 kilometers across where people live. 7 to 7.9 major earthquakes can cause serious damage over larger areas. 8 or greater, or the great earthquake, can cause serious damage in areas several hundred kilometers across. Intensity. Intensity is based on the observed effects of ground shaking on people and building. It varies from place to place within the disturbed region depending on the location of the observer with respect to the earthquake epicenter. The most common scale is the modified Mercalli scale, which uses 12-point scale to describe damage. So here are the Mercalli scale. Intensity 1, intensity 2. So these are not so strong earthquakes. So just intensity 3 is could be noticeable. Intensity 4 can be felt. Intensity 5. So most people felt intensity 6. So this is quite big, can cause damage. Intensity 7. So it will be bigger damage. Intensity 8. So there will be severe damage on poorly built structure. Intensity 9. So there is a destruction, landslide. Intensity 10. So there is bigger destruction. Intensity 11, total damage. And intensity 12, so objects thrown up into the air. So that's scary.